Despite all the advancements in modern agriculture, most of the fresh fruits and vegetables that we eat today are still picked by hand. These are often extremely difficult tasks, and the cost of labor to farmers, if they can find help, is off the charts.
If you look at the cost of harvesting strawberries, just for reference, it's about $50,000 per acre in some cases, which is just incredible.
That's Kyle Cobb, co-founder of Advanced.farm. After successfully building and selling a robotic solar panel cleaning business, Kyle and team set their sights on robotic harvesting, starting with what has got to be one of the most difficult crops to harvest, strawberries.
After we demonstrated that we could pick tens of thousands of berries without damaging them, then the question really became, can we do it economically? Can we do it in a way that can scale?
And Kyle says they have, which is really exciting. But this isn't just a story about strawberries. Advanced.farm has already started to expand their technology into other crops as well.
Fresh fruit and vegetable harvesting is going to look a lot like the mechanization of, corn, wheat, soy, maybe not exactly in how it's manifested in terms of what the equipment looks like, but it will start to look much more automated, much more coordinated at the ranch level. And I think that's a future that's not that far away.
We're talking robotic harvesting with Advanced.farm co-founder and president Kyle Cobb on today's Future of Agriculture podcast. Well, hello, fellow ag nerds. Thanks so much for joining me for another episode of the Future of Agriculture. My name is Tim Hamrich, and every week, you and I get to sit down with the founders, farmers, innovators, and investors shaping the future of the ag industry. Before we dive headfirst into today's episode, I want to take just a minute to recognize our quarterly presenting sponsor for this quarter, which is Acres. Name a place, a single source where you can find land for sale, comparable sales, and easy-to-use maps. Can't do it? Well, that's where Acres comes in. This land analysis and mapping platform brings together the data you need to make confident decisions about buying, selling, or investing in a piece of land. That includes manually vetted comparable sales, soil data, crop history, elevation, flood insights, and more. There's no paywall. You can create a free account today at acres.co and access 10 plus layers of data along with land listings, tools for saving and customizing maps, and PDF report generation. If you're in the land business and need more than just the basics, check out their premium and enterprise plans for features that support efficient due diligence, portfolio management, and fast valuations. It's all part of Acres' mission to make the land marketplace transparent and easy to access for anyone. Check out a parcel anywhere in the U.S. today for free at acres.co. That's acres.co. And thank you to Acres for supporting the Future of Agriculture podcast. Okay, now back to today's episode with Kyle Cobb, president and co-founder of Advanced.farm. They describe themselves as a 21st century ag equipment company centered around robotics with a current focus on automating harvest and post-harvest in fresh fruit. Advanced.farm is based in Davis, California, proudly where I went to college, and has raised over $35 million in venture investment led by Kubota, Yamaha, Catapult Ventures, and Impact Ventures. Before Advanced.farm, Kyle was co-founder of Greenbotics, a cutting-edge platform for robotic solar panel cleaning that was acquired by SunPower in 2013. Kyle and I talk about the journey that has led him and his team to robotic harvesting, the challenges of bringing this type of technology to the market, why Kyle is convinced that now is the perfect time for robotics in agriculture, how they've approached raising money, and much more. I'm going to drop you in the conversation here where Kyle is giving some background on how Advanced.farm came to be. So here is my conversation with Advanced.farm president and co-founder Kyle Cobb.
So I actually went to high school with our co-founder, Mark Grossman. We grew up together up in Chico, California. And Mark, for as long as I've known, has been a tinkerer. Even when we were kids, when I used to go over to his house, he would have robots sort of splayed out all over the place. And that continued into our adulthood. So I went off to study finance and accounting at UCLA and then worked in the finance industry for a little while. And meanwhile, Mark went to pursue an engineering degree at Caltech. And it was only after we were both about 5 years into our careers, of course, we'd stayed in touch, that we decided to take our first leap together. And back in 2010, right when the solar industry was booming, Mark had taken his first job in the solar industry for a company called eSolar, which was building solar power plants using mirrors. And one of the biggest challenges with building solar power plants at that time was keeping the panels or mirrors clean. Because when you build big power plants out in the desert, there's no water and there's no labor. And so one of Mark's first tasks was to build an automated panel cleaning system. We took that insight and started a business around it with a couple of his classmates from Caltech and colleagues at eSolar, guys named Cedric and Carl. And at the time, we decided to move to Davis because when you're building a business on a budget, you move in with your mom. And Mark's mom lived in Davis. And so we moved up to Davis and started Robotics, a robotic solar panel cleaning company. We built that over a couple of years out of a barn and ended up selling it to a customer called SunPower, big publicly traded solar energy company. And after a few years of working with them, we started advanced.farm in 2018. So it's kind of a long journey to get to where we are, but now we're together again.
That's awesome. And so maybe just share briefly on who your customer was with that company and how you thought about agriculture, the agricultural customer, as different, if at all.
Yeah, I think our customer was mostly a solar power plant owner, was sort of scratching their head on how they would make the economics work when soiled panels would reduce their production by 30%, sort of unexpectedly. I think solar was growing so quickly that people hadn't really thought through the maintenance part as well as they have now. I think an interesting delineation, though, is actually not the customer, but the user. The user in our case at that point was, we're introducing really high tech products to a new market with a group of people that are used to using brushes and mops and, buckets of water and hoses to get their job done. And here we are introducing a robot that can do it faster, more efficiently, more consistently, and help that same person have, let's say, better working conditions and better prospects. And so I think that's really a more analogous comparison to what we're dealing with in the farming industry now.
Yeah, that makes a lot of sense. What stands out as kind of lessons from that first company that was so successful that you have been able to apply now with advanced.farm?
There are a few key lessons that keep coming up as we grow. One is to continue on that user story. We had a customer in Chile where we had, for the first time in our careers, we had to send products sort of into the abyss in a shipping container and hope that everything went well with our cleaning robots. And at the time, we thought, great, we have an engineer here who speaks Spanish. We'll convert the menu into Spanish. And once we get there, it'll be easier for them to use. And when we unboxed them in the other side, the person said, hey, I'm sorry, I actually don't read. And so fortunately, we developed the system with big red and green buttons, and we relied on those red and green buttons to keep things going. And so now if you see our equipment, we don't really expect anything from the user. We say, push this green button to have it go, and this red button if there's an emergency, and otherwise it will sort of stop on its own, and here's a joystick if you need to drive it. So I think really keeping some of those core simple design principles in mind was one important lesson for us. And I think another lesson was really sort of match your product for the user's budget. When we first started cleaning, we thought, we'll sell cleaning robots. And the owners of the power plant said, we don't have a budget for cleaning robots, we have a budget for cleaning services. And so I think we were a little bit more careful as we entered the farming market to see, how does harvest work today? How should we adapt our business model? And how can we really ease the transition to this new technology from the user's point of view?
That's great. And you kind of mentioned this, but how did you conclude that 2018 was the right time for robotics? And this is something I always like to talk about anytime we have a robotics type episode, which is we've been talking about robotics for a long time. And so sort of the why now question. And I'm curious two things. Number one, why did you think 2018 was the right time? And then number two, what has happened in the 5 years since that has either validated or made you question, that assumption?
Sure. Well, I think there was a little bit of blind optimism, as there has to be with any new startup. So I don't want to pretend that we had it perfectly right at the beginning. But I will say that, again, I'm very fortunate to have just really bright technical co-founders that have solved really challenging problems and that build things as a hobby. So understanding that it was the right time, I think, was more a question around the acuteness of the pain for the growers. So I think, with any startup, the most important thing is to address a really pertinent problem with a big opportunity. And I think it's very clear if you ask anyone in farming, the biggest challenges that they face are labor, and labor. And in some cases, water is closely behind it. So the timing was really dictated by the importance of solving this problem. From a technical point of view, I think as we got into it, we realized that the timing was also good because a lot of the platform or the components that are required to build a technology that would work for this application really weren't around until recently. And in fact, over the last 5 years since we've started, we've seen that tech stack continue to progress to our benefit. And so companies that have really smart teams who maybe would have tried to solve this 10, 15 years ago just wouldn't have access to those same tools. So we're really lucky that in addition to having a big customer pain, we had a lot of technical tools at our disposal.
And does that point apply to hardware as well? Because that was my first thought with strawberries. It's like, if I had to pick a fruit that was so easy to mess up, it would be strawberries. I mean, it's just the good ones, the ripe ones are soft to the touch, even a human touch. So is that part of what has changed? And maybe talk about that particular challenge in what you're trying to do.
Certainly. When we started, I think when anyone starts picking strawberries with robots, the first question that we were asked by growers was, are you going to damage fruit? And I think that was where we had to spend a good portion of our time de-risking the first rollout of the technology. So if you look at a lot of our old videos, it was less about speed of picking and perfectly applied into the fields. It was more about, can we develop a gripper that can softly handle the fruit? Can we delineate ripe fruit from unripe fruit? And so that was certainly the big first step for us was de-risking that. And then over the last several years, the biggest challenge has changed depending on the phase of the company that we were in.
And then can you talk about that? How has it changed? To say more about that.
Yeah, no problem. So after we demonstrated that we could pick thousands of berries, tens of thousands of berries without damaging them, then the question really became, can we do it economically? Can we do it in a way that can scale? And I think that's really where I can point again to the tremendous aptitude of my technical co-founders. We see startups make a couple of mistakes when they enter this space. One is taking off-the-shelf components to try to solve the problem. And what ends up happening when you try that is a couple of things. One, the tech is usually far too expensive to ever pencil out. So, immediately if you start buying an off-the-shelf robot and off-the-shelf cameras and put it on the back of a tractor, you're in for several $100,000. And when you run the numbers, even in the best of circumstances, you just can't pay that capital back. And so that's an insight that we unpacked pretty early on. And then the second problem with the off-the-shelf technology is it's not quite right for the application either. So you bring robots that are meant to work on an industrial floor with 0.1 millimeter repeatability on putting a chip on a board. You can't even use that repeatability in the field because you hit a bump or a leaf moves. And so we took on some audacious tasks of building our own first gripper, as I talked about, and then vision system, and then robot, and then tractor. And if you look at our system now, it's not obvious, but what we've really done is we've built a platform for the future of ag robotics in the field that is really highly performant. It's also cost effective. And that's helped us tackle these different challenges along the way of, can we pick a berry gently enough? Can we do it quickly enough? Can we integrate it into a field full of humans? And I think the answer, after a lot of hard work, is now yes. And now we're at the point where we can scale our operations and give growers a tool that they can use every day.
Awesome. You specifically said, you've built a platform, not just a picker. And can you maybe talk about the differences between the two?
Sure. Part of it is, I think there are companies that have demonstrated that they can pick a berry gently and maybe even quickly, but can you do it repeatably in various conditions with different strawberry cultivars on different bed widths? And I think that's where the system has to demonstrate its robustness over time. So, we've picked millions of berries now for several growers. And I think that's a good demonstration that we're over that initial hump of being not a prototype, but, at least closer to a product than anyone has ever been. I think another demonstration of it being a platform, not just a product, is how can we apply this to other commodities outside of strawberries? And so we've taken a lot of the same systems that we've built and adapted them, or in some cases, reused them directly to pick fresh apples on a trellised orchard format up in Washington. So I think we're the first company to demonstrate that we've developed a tech that doesn't only work for one fruit, but for multiple.
And I don't know much about strawberries, but I would think that there's a lot of factors that go into whether a strawberry is ripe or not. Are the genetics such that once you're going to harvest strawberries, just go in and pick all the fruit? Or is it still like you need to make sure you're only picking the fruit that is ready to be picked? And if so, how do you do that with a robot?
It is a selective harvest. And I think this is one of the things about strawberries that makes strawberries a really attractive market, but also a really tough technical problem. So when you plant strawberries, you plant them, let's say for the southern part of California, 90% of strawberries are grown in California in the US. And so when you plant a strawberry plant in, let's say, October or November, you start harvesting in December and January, and you start to see flowers come up off the plant. Those flowers turn to green fruit, and then that green fruit turns into red fruit, and more flowers are coming. So as you harvest the red fruit, you have to be very careful, first of all, not to damage that fruit so that the consumer still likes the way it looks in the grocery store. And also not to damage the green fruit or flowers or plant that you've picked around. So that's why humans in the past have been so great at this task, right? Because we have a great vision system. We can be very gentle with our picking, and we can move very quickly through the field. If you look at the cost of harvesting strawberries, just for reference, it's about $50,000 per acre in some cases, which is just incredible considering the cost of harvesting an acre of corn is $20 an acre per year. So it's a tremendous opportunity, but a really hard technical problem, and one that we've had to work hard to solve over time.
But I think that maybe the silver lining there is that you're going over an acre multiple times for the harvest, so you can utilize the robot more than just kind of once a year per acre.
You got it. Yeah, it's a really tremendous market from that point of view. One, because the grower can utilize the tech and pay it off, by keeping it in the field for, let's say, 6, 9, 10, 12 months a year, depending on where they're harvesting. And the other great part about that from a startup point of view is that we have a lot of opportunities to perform R&D, right? So it'd be a real shame if you get one chance every year to go out and see if the new end effector you developed over the last 11 and a half months is going to work out. In our case, we can make changes, and we do make changes both to software and hardware many times per week, just as we try to hone in on the right solution. And that's been a great opportunity to build a really attractive business here in California.
That makes so much sense. As you're harvesting, you are seeing the flowers and the green fruit that aren't ready to be harvested. Are you collecting that data to give the grower maybe a better optimal time to come back in and harvest again? Is that sort of a part of the value of using robotics for this?
The harvest is pretty well defined. It's on a 2 or 3 day rotation. So if I visit 1 acre on Monday, I'll come back on Thursday. But I think what's really interesting is that's not really the application for data in this case. If I could step back and think about the people who are trying to collect data and the way it's collected today, right now there are literally hundreds of workers who show up every day onto a ranch. And it's such hard work that it's all the grower and the harvest crew can do to get through the field, right? To pick the fresh fruit before more fresh fruit's coming. So that's a really tough task in itself. And so as a result, it's not really a priority or easy to draw out scaled insights about what's happening around the ranch. Of course, pickers are really good at identifying there's more fruit load here than there. I want to go down this row so I can pick more. But often that doesn't make it back to the harvest crew manager or even the grower. And so what you end up seeing is decisions are made on sort of a ranch level in a lot of cases. People have tried to implement different new ways to collect data, but those come at a cost. I think what's really interesting with what we're doing is we are solving the highest priority problem for the grower, and the data that we're collecting is actually an artifact of the process that we're doing. So we're taking 25 frames per second of video footage of every meter that we're covering. And so I think as we start to get to scale on a ranch, what we'll see is we can programmatically look at those insights for growers and say, hey, we should really send your pest control advisor over to this part of the ranch because this part of the ranch seems to be producing far less based on how many pick attempts we've made over the last week and a half on this particular area versus the others. And then when you start to really look forward to what that can do is then we can start to be more targeted with our spraying and our pest applications in ways that have never worked before or even been tried really at scale before. So I'm really excited about not only the direct application of robotics, but also what it enables as we start to look into the future.
Yeah, you can actually have more precision agriculture. I mean, in specialty crops. Well, walk us through kind of the economics for a farmer to look at this. You mentioned the cost being $50,000 an acre to harvest strawberries. How much is this going to save them, or how does that economic decision look for them?
Well, I think for us, the first goal is to solve this gap in labor that currently exists because this is really hard work that is hard to find workers for today. So while I do think that as we look to other examples of how autonomy have been applied to other industries, I think there are cost savings opportunities. I would say our first goal is actually to help growers solve this labor gap at a cost competitive rate. So at least until we're at scale, we likely won't see a significant reduction in cost for growers. But I think for them, it's really important to stabilize their cost structure as wages double every decade, and again provide a steady supply of harvesting that can work alongside their human crews. To answer your question more directly, I do think that over time, as we transition to robotic harvesting first, or robot first farming, let's say, where you just start to design the ranches around using robotic harvest with human harvest alongside it, rather than humans with robotics alongside them, I think we will see opportunities to save 25-50% of costs over time.
Wow, great. And how many people does it take to harvest? I don't know what the right metric would be. Harvest an acre of strawberries. How many man hours, I guess, to harvest an acre of strawberries versus kind of what this is able to do from a efficiency standpoint?
Right. So maybe the best way to say it, I'll kind of rephrase it in different metrics. So right now, the average person can pick somewhere between, let's say, 100 and 150 pounds of fruit, for fresh fruit, per man hour. And our robotic harvesters are about at that same rate. But where it starts to get really interesting is one person can operate multiple harvesters at a time. So we deploy our harvesters in fleets, and one operator can press start on 5 different harvesters and manage that fleet. So all of a sudden you're seeing one person pick 750, 1,000 pounds an hour with robotic harvesting. And we can do that day and night. In fact, our robots sometimes prefer to pick at night. And right now, the human labor workday is getting shorter and shorter with new regulation. And so I think that's really where we start to see the leverage is running day and night and growing the number of units per operator, or growing our fleet size per man hour.
And what do you mean your robots prefer to pick at night?
We control the lighting in any case. So if you look at our picture of our harvester working during the day, you'll see that we block out the sunlight, and then we make our own light underneath the hood to improve our chances of picking a red berry versus a green berry. At night, we don't have to do that. And so, the lighting is even more controlled, and sometimes the conditions are even better for the robotic harvesters than they could be during the day.
And what does that training look like? How has that been? And what lessons have you learned from making sure that people are well trained to work alongside robots? Because I think this is going to be a conversation that comes up often in the coming years. How do we train people to work with robots?
I think it starts, to be honest, with the design of the machine. Designing with the end user in mind, as I've talked about before, making sure that it's really practical. I think in the earliest stages of a company, it's hard not to have an engineer out at the equipment, because a lot of times you get a lot of learning from being there with the equipment. But for us, very early on, we've made the decision that it's important to understand our user. And so the training, if you really wanted to use one of our harvesters, the training is actually like 10 or 15 minutes, and you refine your ability to drive the machine over time. But typically, we're really focused on providing excellent customer service. And so we don't spend just 10 or 15 minutes. We typically spend a week on a customer's site. What we found is that we've hit this point where it's actually less about the technological improvements that we're seeing, and more about the integration onto a ranch that will maximize the operational efficiency and lower the cost of harvest. To give you an example, one of the biggest sources of downtime is when a robot is stopped at the end of a row. So a robot stop at the end of a block of strawberry beds so that we can unload fruit and just for safety reasons before we cross the road into another bed. And so training operators on how to manage a fleet of harvesters so that you can sequence the timing of when a robot is stopped, when a harvester is moved across the road versus the other one stopping, and really understanding that cadence is a really important part. I mean, it probably moves the needle, 10, 20% on our cost structure. And so sharing those insights have become more part of the training than they initially were. And I think developing that sort of set of best practices and really learning from our operators who are developing those insights as they're running every day is a really important part of our business going forward.
So cool. And you are early, I guess, in the California season, just started this month. Where are you all at if we look at it on a season to season basis? So where are you all at right now, and what are your hopes for this season to be bigger and better than last season?
We've grown our fleet almost twofold every year, and this year we're at 16 units under contract with some of the leading growers in Oxnard and Santa Maria. We're picking tens of thousands of berries every day, if not more. So we're really starting to make a dent for our growers. I think what's really cool for us is when we see a grower who's been following our progress over several years, hosting them after 6 months of sort of an off season for them to see our harvester. I think we're still at the point where they raise their eyebrows, and we're still making pretty meaningful progress on a day-to-day, week-to-week, certainly month-to-month basis. And so I would expect that if you have seen our harvester before and you were to come out this year, you would see a significant increase in reliability and usability, and then a significant increase on the speed of picking, the quality of picking. And there's still some work to do, but I'm really proud of where we are now. And now we can start to shift our focus to more of those operational insights. So one other thing that you'll see this year that's really exciting is, I think for the first time, we're going to be responsible for the entire harvest, let's say, at one of our ranches. And so you'll see a giant fleet of robotic harvesters, bigger than we've ever had before at one ranch. And I think that's when we're really going to start to see the tipping point for scaled economics and really figuring out some of these operational issues.
Right on. And I know you all have raised some money, a fair amount of money in venture capital. I'm curious, going back to your first startup, did you raise venture capital for that as well? And what lessons did you learn from one venture to the other that you applied to Advanced Farm?
The first time we started a business, Robotics, we bootstrapped it. We took some friends and family money and put our own savings into it. And we were much younger at the time, and we had very supportive spouses and significant others that I think helped float the bills. I know my wife is no exception to that. She worked hard as a nurse while we were growing the business, and that was really hard. And I think as we got into Advanced Farm and we were in a slightly different stage in our lives with respect to our families and growing families and having children, I think we realized that there's some value in bringing on bigger investors. And so we were fortunate at a very early stage to bring on a seed stage hardware investor named Catapult, who's been a great partner to us. And then we brought on Yamaha and Kubota, the big Japanese industrial companies. Of course, Yamaha has a big presence in robotics, and Kubota has a big presence in agriculture. And they've also been tremendous partners for us. And I think we're at the point now where we can start learning from them as manufacturers of equipment that's sent all over the world without an expectation to get it back. And how do we do that in an efficient way that delights our customers? And I think we're just really pleased with the partnerships we've built, and I'm excited to continue to leverage those going forward.
Well, I'm sure, I guess I'm not sure, but I would imagine one of the questions a venture capitalist would have about this is like, okay, well, how big of a company can be built in strawberries, and how easy would it be to go to other crops? And I know you've already mentioned apples, so maybe talk about that, the size of the strawberry market, and where are the next obvious levels, places you could progress into as far as other crops.
Sure. I think I'll start again at the acre to acre comparison. when we look at harvesting an acre of broad acre crops, cotton, soy, wheat, corn, it's been largely mechanized over the last 50 years. And so that costs about $25 per acre per year to harvest. Strawberries are upwards of, $30, $40, $50,000 per acre to harvest. Apples are several $1,000s per acre to harvest. And I think, in the history of time, every piece of fresh fruit and veg that's presented to you in the grocery store has been picked by hand. It seems like a natural progression to, now that we have a lot of the technology available to build solutions to enter into fresh fruit and vegetable harvest, that's the next frontier of farming. We see it as about a $40 billion market just with tree fruit and strawberries harvesting around the world. And I think the other thing that's really interesting, as we and others have made progress in implementing robotic harvest solutions, we're starting to see growers really take a forward view on how they're going to adapt their orchards or farms to be more prepared for automation. And this is why we're really excited about the work in the apple industry. And in other tree fruit, we're seeing a tremendous shift that in most cases has already actually happened to this trellis format that really favors automation. And so if I were to go back and answer those venture investors, the biggest opportunity in agriculture right now is to crack this nut of fresh fruit and vegetable harvesting. And I think we're the leaders in that space, and I'm really excited about that.
Man, this is I love this. This is really cool. I don't know. I have really just enjoyed the robotics episodes that I've done so far. I think it's exciting. I guess one question for you, and I'm asking you to speculate or sort of project here a little bit, but as far as the technology, what do you see as possible here as far as how much more efficiencies could you gain in the technology that your team is building? And if we were to kind of hope and dream about what one machine could do, what do you see as potential here?
I see a lot of potential. I think we're just sort of scratching the surface on where we are because every year compute power goes, up and up, and we can take advantage of all of those advances in processing power directly for our system. So I think that's, we expect to follow Moore's law on that front. I think the other thing that I've started to mention is the operation, sort of growers meeting us in the middle. We've always wanted to be a company that went to where growers are today. So we never ask growers to change anything because it's just another point of friction in growing the business. And so now that we've made a lot of progress on the technical side, growers are starting to ask us how they can change. What are the right cultivars to use? How can we change our growing system to make fruit more visible? And those are really great questions and questions that we don't have the answers to. And so I think when we look at kind of the remaining improvements, there's a tremendous amount of technological improvement that we will continue to, to push forward with R&D. Then there's also a lot of things that we haven't even conceived on the operational side, on the genetics side, that we have seen in other crops that encourage me to think that fresh fruit and vegetable harvesting is going to look a lot like the mechanization of corn, wheat, soy, maybe not exactly in how it's manifested in terms of what the equipment looks like, but it will start to look much more automated, much more sort of coordinated at the ranch level. And I think that's a future that's not that far away.
All right, one more question, just because it just came up and I hadn't seen this before on your website. Making video games for robots to play. What is that all about?
Oh, I'm glad we hooked you. So one of the other really innovative things that we've done actually came from some really good advice from one of our mentors was emulation of the farm or basically creating a virtual digital twin of the farm. When we would go out early on in our company and test, we have this new breakthrough that we thought we'd have on the software side or even on the hardware side. We'd go, let's say on Monday and harvest, and on Tuesday we'd try to test the new feature, but the plants would have changed or something about the conditions were different. And it made it really hard to understand if the impact of our change was positive or negative or neutral. And so for that reason, we developed a virtual environment that allows us to basically test all of our code all the time. So it runs our whole code base. Every time we push through a new update, it's one of our testing stops where we say, go pick as many berries as you can in emulation, see if there are more or fewer or the same. Make sure you get all the way down this fake row of strawberries without any reliability issues. And it's just allowed us to make a ton of changes really quickly. But the other really interesting thing that's happened is we also did the same approach when we moved into the apple market. We took a bunch of plants sort of measurements and developed a virtual twin of an apple orchard. And before we ever picked an apple in the physical world, we were picking thousands of apples in emulation. And so what happened is our first day of harvest on apples, once we had our hardware there, we had made decisions about what number of arms was optimal versus the capital expense. What's our baseline for what we can expect to harvest? And we picked thousands of apples on our first night of harvesting, which I think is just a significant improvement from our learning in strawberry.
Absolutely. Great. Well, Kyle, I really appreciate this. Before we close out, anything else we didn't get to, or just something you'd like to either close with or emphasize before we wrap up?
I guess the only thing that I would encourage the listeners to do, as I always do, is if you want to learn more about us or any of the other things that you hear on other episodes of this podcast, just come out to a ranch. I think it's so informative to get out onto the ranch, and I'd certainly be happy to host anyone who's interested, even if it's not for a demo, just to learn more. And we always welcome feedback. So go out and visit your local farmer.
Well, that is great advice. Go visit a farmer, and also go visit Advanced Farm's website to learn more about the cool stuff they're doing. That website is just advanced.farm, and I'll leave a link to it in the show notes. Thank you so much to Kyle for being on the show. And special thank you to Tommy Bottoms, my friend and former guest of the show and California farmer, for recommending Kyle for this particular episode. Very much appreciated, Tommy. One more reminder to go check out acres.co, and thank you to Acres for being our quarterly presenting sponsor. And last but certainly not least, thank you for your time and your attention. I never take it lightly. I'll be back next week with another story of ag innovation.